This is Branebender, a wavetable synthesizer that I created in Contact. And this video is a branch of instrument guide, in which I will be talking about section named Kinematics. If you haven't seen the main guide video, it may be a good idea to watch it first. This is the part of the instrument where you create internal automation. It automates XY pads, which in turn control different parameters like oscillator mix or filters. A quick summary of what has been covered in main video. In kinematics, you define movement of XY pad cursor. I will call each such definition a simulation. There are 6 simulations. You use these icons to switch between them. Then light bulb icon switches individual simulation on and off. And kinematics label switches the whole engine on and off. When the engine is running and a simulation is active, it takes control of attached XY cursor. At this point in main video, I concluded that the whole section is somewhat optional, and you can simply use presets. Now I will try to explain how all of this works. First off, each simulation has 2 modes. One is called path mode, and it's a kind of draw by numbers game. The cursor will travel from checkpoint to checkpoint. The other is called dynamic, and it's a ball in the box game. Cursor will have a vector, speed, and will travel through the pad area, bouncing off the edges. Use compass icon to switch between modes. I'll start with dynamic mode, which was the first one I added to the instrument. The simulation area is this grid box on the left. It's an XY pad with 3 cursors. So you need to grab a cursor and drag it with mouse to set its position. The circle cursor is a virtual ball or a particle. When the engine is active, it will be animated and its movement will be applied to target cursor. The cross is the origin. It represents the starting point of the simulation. The simulation can be restarted, so you can replay cursor movement in your workstation project. It can restart automatically as transport starts. Also, you can define a Restart MIDI button and restart all simulations at any moment as a part of performance. These options are in Setup section, which was covered in main video. There are 2 buttons related to setting up cursor origin point. Parachute Lunar Lander module and Drawing pin. Parachute is equivalent of simulation restart. It moves main cursor to origin point. Also restoring vector angle. Pin does the opposite. It sets current cursor position and angle as new origin point. Then there is X cursor. It's named center of gravity and is reference point for rotating function. Now let's talk about the meaning of the pad area graphics. The grid defines snap points. Hold Ctrl key while moving a cursor to snap it to the grid. The big circle is alternative bounding box. Main cursor can bounce within square box of pad area or within the circle. Use this button to decide which you prefer. Then there are 4 arcs between opposite corners of the box. They are related to oscillator mixing pad, which is controlled by Sun simulation. Let's look at Bender section. So there are 4 oscillators, named A, B, C and D. Mixer pad is between the 4. Oscillator volume depends on how far Sun icon is from oscillator corner. Look at volume level sliders on the right. Back to Kinematics page. The arcs define oscillator area of influence. So oscillator A is in top left corner. And this would be its arc. When cursor goes beyond this line, oscillator A is completely muted. Let's check. I'll go back to Bender page, mute oscillators B, C and D. Now turn Kinematics engine on, so cursor movement would be applied to target pad. OK, let's turn all oscillators back on. Finally, there's the small circle, which is essentially meaningless. Now about the cursor. In dynamic mode it has three basic properties: position, azimuth and speed. Azimuth defines the direction it is moving in and is controlled by a racket icon, which acts as a knob and is defined in degrees. Then speed is controlled here. Let's see. A digression here. Switch star map button to visualize cursor path. Each point in the path is a contact interface object, and there is limited number of those, so the visualization has limited number of dots. And it looks a bit like a comet tail. You can adjust tail length by defining number of trail points. And adjust point spacing by defining trace step. Back to cursor properties. Speed is fixed and azimuth is variable. As you see, it changes on each bounce. Therefore, origin point also has an azimuth. When simulation is inactive and I switch between main cursor and origin point, I can adjust azimuth for each of them individually. Then the icon here is azimuth toggle. Click on it to move azimuth by 45 degrees relative to 0 point. It reacts to key modifiers, so hold Ctrl to move by 15 degrees, Alt key to move by 18 degrees or Shift to move by 1 degree. Use it with Snap to Grid and you can create different basic geometric shapes. Then there is additional cursor property named spin. It's controlled here. It adds azimuth movement, so cursor won't move in a straight line, but it will change direction as it moves. And then there's rotation. It will move the cursor around the X point on top of any other cursor movement. It's also the simplest way to draw a circle. You just need to set the speed to 0 and place cursors. Rotation speed is defined in degrees per half node. Don't ask why half. So set it to 180 degrees and it will take whole node to make a full turn. At 90 degrees it will take 2 whole nodes and so on. It's a good moment to mention that the whole engine is tempo synchronized. Basically it makes a step on every MIDI tick. Also each simulation has speed slider, which acts as divider. You can play it back at half speed, 1/3 speed and so on. So you can define a movement, test it and then play it back very slowly, which could be nice for making ambient pads. You can experiment combining speed, spin and rotation to create different shapes. However, with the three forces in play, you will notice that it gets quite hard to predict the end result. You would set up initial parameters, play the simulation, try to tweak something, play again and so on. To make that process more manageable, I added a function named offline trace, which will play the simulation fast forward, revealing result shape. To enable it, use telescope icon. Now it will update the shape as you tweak parameters. This function has some limitations. It is using brute force to predict the end result, so it basically plays every step as fast as possible, placing trace points along the way. In effect, it creates high CPU load. As you can see, each trace takes several thousand steps to complete, and the number will grow if you add trace points or increase traced step. So rather don't use it when you play sounds. It will likely cause audio glitches. And don't expect smooth response when tweaking parameters. Also, it is only available when Kinematics engine is off. As a side note, offline trace updates when you load presets, so it is a smart way to browse them. Let's see. Now let's look at spin again. Alone without rotation or bouncing, applying spin will result in drawing a circle, which is not particularly interesting. Spin has alternate mode of operation, where amount of applied spin will depend on cursor position in the box. It will get slower as it gets closer to the center of the box. Turn it on or off with the button next to spin controller. Similarly, rotation function has the same mode. Just note that it is always relative to the center of the box, and not X cursor, which defines center of rotation. There's another force you can apply to simulation, which I named pulsar. It has three parameters with controllers just below rotation knob. Pulsar rhythmically scales the simulation space towards the center of gravity, that is X cursor. Think of it like applying an LFO to the box size. There are depth and speed controllers. And shape switch. You can choose between linear and sinusoidal motion. Think triangle versus sine as in LFO shape. A digression concerning rotation function. You can observe that it is possible to push the cursor outside of box area, as you set X closer to the edge. What happens in such situation is that cursor path will be calculated outside of the box, even though cursor position will be clipped to box boundaries. Okay, now let's talk path mode. There is no azimuth, no speed or spin here. You define cursor path by placing checkpoints, or path points as they are named in user interface. The starting point is represented as cross, just like in dynamic mode. And following checkpoints are numbers. Currently, there are just 2 points. You can control number of checkpoints with plus and minus buttons, or just click and drag the number. You can have up to 12 checkpoints. You define simulation speed by setting path time in terms of node fractions. Path time means how long should it take the cursor to travel through all checkpoints and back to starting point. Or you can switch to section time, where you define how long it takes cursor to travel to next checkpoint. As you see, in this mode, cursor speed depends on distance to next checkpoint. So far, this is quite simple. As you can see, pulsar, rotation and spin controllers are still visible. Pulsar works the same way as in dynamic mode. Then rotation is applied not to main cursor itself, as it has to travel between checkpoints, but instead to all checkpoints. Now the spin controller. which is not spin. In this mode, it's the second rotation movement, where center of rotation is the starting point, that is cross cursor. Then you can combine both rotations for some quite brain-bending results. There is just one controller left to explain in Kinematics section. Update frequency. You can use it to change automation vibe from LFO to step sequencer. Although the whole engine is already a kind of step sequencer, just with many steps per bit. But then I could argue that every digital synthesizer is a step sequencer, as everything digital is quantized to steps. Anyway, default update frequency is continuous, which means that cursor movement is applied to target cursor and in turn to sound parameters on every simulation step. You can change that and update, for example, on every 8th note. Now simulation step is calculated as usual, but it is being applied to cursor only at selected rate. So it will make the cursor jump along its path. Note that you will need to restart the sequence for the rate to align with starting position. Now let's switch to Bender page. We have filter control automated and it affects cutoff frequency and resonance in full parameter range, which is not always desirable. You could manipulate simulation path to cover smaller area, but that's not always an option with more complex shapes. Note two sliders beneath filter type name. You can use them to scale down automation range. First slider controls cutoff range. And the second, resonance range. There are similar controllers for Sun and Saturn icons, so oscillator mixer and wave bender. Let's check how it works. You can also disconnect the automation completely. Let's automate wave bender too. Bender automation amount slider is bipolar, so you can decide which side of waveform morph you prefer. Note that you can exclude waveform morph automation on oscillator level. Click on top left corner of waveform graphic. Now the waveform is locked. You can still set morph point with bend level table, but Saturn cursor movement will not affect it. Okay, that nearly covers everything related to kinematics. Let's just have a look at setup page. There is section named MIDI mapping. I haven't tried newer Contact versions yet, so maybe that has changed. But in Contact 6 you can't just right-click and land MIDI CC to XY pad cursor. So there is mapping support at script level. If you have a hardware MIDI touchpad, you can use it to add automation. Just choose a cursor, press Learn and move the controller around to change position in both axes. There are also invert buttons, so you can correct the input if the controller automation is backwards. Just note that if cursor is being currently automated with kinematics, MIDI automation will be ignored. It will be hinted by adding @sign as prefix to cursor name. Finally, note that for each of 6 simulations, you also have CC out option. Set it to a value different than -1 and you can use kinematics to control another instrument. Just remember to enable CC output in Contact options. I think this is all for Brainbender kinematics. Cheers!